Hello everyone, and welcome. I'm excited to kick off this presentation with you today. Our topic is REST integration in ServiceNow. On this first slide, you'll see the title clearly displayed. We're going to explore how REST API integration works within ServiceNow and why it's such a powerful tool. Over the next few slides, I'll walk you through the key concepts, benefits, and some practical examples. So, let's get started and dive into the world of ServiceNow integrations. Let's talk about the introduction of REST integration. Essentially, this involves two different applications that communicate with each other and share data. We call this process integration. Now, when we ask, what is integration? We're referring to how these applications work together seamlessly. Imagine application 1 and application 2. These are two separate systems. When they need to exchange information, they do so by communicating. This communication allows them to share data efficiently and effectively, enabling more powerful and flexible systems. Understanding this concept is fundamental as we explore how services facilitate this kind of integration in modern applications. Let's take a closer look at the different types of integration we encounter in systems. First, there's outbound integration. This is when a system sends data or information out to other systems or external partners. Think of it as the system reaching out to share updates or send data to another platform. It's crucial for sharing information across different parts of an organization or with external entities. Then we have inbound integration. This is the opposite. It's about receiving data or information coming into the system from outside sources. This could be data coming from suppliers, customers, or other external systems. Inbound integration ensures that the system can effectively process and utilize incoming information. Both types are vital because they enable seamless communication and data flow, which is essential for achieving a cohesive and efficient system environment. Understanding these helps us design better integrations that support our overall goals of connectivity and data consistency. All right, let's talk about what outbound integration really means. Essentially, it's when ServiceNow makes a call to a third-party system to share data between the two systems. So, imagine ServiceNow as the provider of the data, reaching out to another application, which we call the consumer. The process starts with ServiceNow sending a request, which is like asking the third-party system for information or to perform a task. Once the third-party system receives that request, it processes it and sends back a response. This entire flow involves a few key components: the ServiceNow instance, which is our platform where everything happens, and the third-party application, which is the external system that we're communicating with. It's important to understand that this process is a two-way street. ServiceNow initiates the request, and then it receives the response. This is how data sharing and integration work seamlessly across different systems, helping us automate and streamline our processes while ensuring all systems stay in sync. By connecting ServiceNow with other applications through outbound integration, we're effectively expanding our reach and making our workflows more efficient. So let's talk about what inbound integration actually is. Essentially, it's when another system makes a call to ServiceNow to perform various operations. These operations can include creating new records or updating existing ones, which helps keep data synchronized across platforms. Imagine a third-party application or provider that needs to interact with ServiceNow. This setup allows them to communicate seamlessly. The third-party system sends a request to ServiceNow, and then ServiceNow processes that request accordingly. On the flip side, ServiceNow can also send back responses to confirm that the operation was successful or to provide additional information. This flow highlights a key concept. The interaction is initiated by an external system, which makes requests, and ServiceNow responds accordingly. It's a fundamental part of integrating ServiceNow into broader IT ecosystems, enabling smoother workflows and better data management. Throughout this presentation, understanding how these inbound calls work is crucial because it underscores how ServiceNow can serve as a central hub, receiving and acting on data from various sources to support efficient operations. REST is actually short for representational state transfer, which is a style of architecture for designing networked applications. It's one of the main ways to create web services that are simple, scalable, and easy to maintain. One of the key features of REST is that it's stateless, meaning each request from a client to a server must contain all the information needed to understand and process that request. This approach helps improve performance and reliability because the server doesn't need to remember previous interactions. REST is highly recommended by ServiceNow and many other platforms because of its simplicity and efficiency. So, what exactly is REST? Well, it leverages standard HTTP methods to perform different operations on resources, which are typically represented as data objects. Let's go through these methods. First, GET is used when you want to retrieve data from a server. It's like asking for information without changing anything. POST, on the other hand, is used to create new data or resources. Think of submitting a form to add a new record. PUT is used to update existing data completely. If you want to replace a record entirely, you'd use PUT. Delete is straightforward. It removes an existing record from the system. There's also patch, which is a bit more flexible. It allows you to update just a part of an existing record rather than replacing it entirely. This can be very useful when you only need to change a few fields. All these methods together form the core of how web services operate, making interactions predictable and standardized. This overall approach aligns with the theme of building efficient, scalable, and interoperable systems, which is essential in modern web development and platforms like ServiceNow. In this slide, we're looking at how ServiceNow functions as a web service provider. When a third-party application needs to interact with ServiceNow, it sends a request using REST APIs. These APIs act as the communication bridge, allowing external systems to interact securely and efficiently with ServiceNow. The third-party application will send a request to the ServiceNow Instance API, which is basically the gateway for these interactions. One common example is creating a new record in the incident table. When a request comes in, ServiceNow processes it and creates the record in the database. After that, it responds with the details of the inserted record, confirming that the operation was successful. This process highlights how ServiceNow enables seamless integration with other systems, allowing organizations to automate and streamline their workflows. It's a key part of understanding how ServiceNow acts as a central hub for various applications and services in your IT environment. Let's take a closer look at some of the key APIs that enable seamless integration across our systems. First, we have the Table API, which is essential for managing and manipulating tabular data efficiently. It allows us to interact with databases or data sets in a structured way. Next, the Attachment API plays a crucial role in handling files and attachments, making it easier to upload, retrieve, and manage documents or media within our platform. Moving on, the Email API is vital for communication processes, enabling automated email sending, tracking, and management, key for maintaining consistent engagement. Then, we have the Aggregate API, which helps us combine data from different sources, providing consolidated insights that support informed decision-making. Lastly, the ServiceNow APIs are integral for integrating with ServiceNow workflows, automating IT service management tasks, and streamlining incident handling. Together, these APIs form a robust foundation that supports our overall goal of creating a more connected, efficient, and responsive system. Let's take a closer look at the REST API Explorer in ServiceNow. This is a powerful tool that allows us to interact with and test the APIs directly within the platform. It simplifies the process of understanding how different endpoints work and helps us troubleshoot issues more efficiently. With the REST API Explorer, we can easily generate requests, see the responses, and understand the data flow. This is especially useful when building integrations or automations, as it provides a clear, hands-on way to explore the available APIs without needing external tools. By leveraging this feature, we can ensure our integrations are accurate and efficient, which ties back to our overall goal of streamlining workflows and improving system interoperability. It's a key component in making the most of ServiceNow's capabilities and empowering us to develop smarter, more connected solutions. All right, now let's move on to selecting the method for accessing our API. The key point here is the URL endpoint, which is essentially the address we use to connect to the API. When working within ServiceNow, we have a handy tool called the REST API Explorer. This Explorer makes it really straightforward to test and explore different API calls without needing to write all the code up front. It's a powerful feature because it allows us to interact directly with the API, see the responses in real time, and understand how to structure our requests properly. Using the REST API Explorer helps us ensure that our endpoints are correct and that the data we send and receive is formatted properly. It's especially useful when you're trying to troubleshoot or validate your integrations. So, in the context of our presentation, choosing the right URL endpoint and utilizing the ServiceNow REST API Explorer are critical steps. They help us streamline the integration process, reduce errors, and make sure we're working with accurate data. This all connects back to our theme of building efficient, reliable API connections that support our overall automation goals. Now, let's walk through how to create and test a table API in ServiceNow. First, you'll want to go to the REST API Explorer page and select the GET method. Make sure to open this page in your personal instance so you can follow along easily. Next, you need to choose the table you want to work with, for example, incident. Once you've selected the incident table, open all the incident records. From there, pick a caller ID and filter the records to show only those related to that caller. When the filtered results appear, you'll see a link above the records. Click on that link and copy the query from it. Now, take that copied link and paste it into the sysbarm query field. Make sure to set sysbarm display value and sysbarm exclude reference link to true. These options help you see readable values and exclude unnecessary links, but don't change anything else on the form. After that, click the Send button. If everything goes well, you'll see a status code 200 OK, which means the data has been successfully retrieved. Copy the endpoint URL from this response and head over to Postman, which is a handy tool for testing APIs. Paste the URL into Postman and make sure the method is set to GET. Next, go to the Authorization tab, select Basic Auth, and enter your instance's admin ID and password. Hit Send again, and you should see all the incident records related to your query. Finally, if you're interested in retrieving specific fields rather than all data, you can go back to the REST API Explorer form. In the sysbarm fields parameter, specify the fields you want to fetch. This way, you can customize your API calls to get exactly the data you need, making your process more efficient and targeted. All right, let's walk through how to integrate ServiceNow REST APIs using Python. First, you'll want to go to the REST API Explorer form within ServiceNow. Here, you'll find various code samples, including scripts in ServiceNow Script, JavaScript, and Python. This is really helpful because it gives you ready-made templates to start from. Next, you'll want to select the Python sample code and copy it. Once you've got that, open your preferred IDE, whether it's VS Code or another tool you're comfortable with. Paste the copied code into your IDE. Now you'll need to update the code with your admin credentials, specifically your admin ID and password, by entering them into the designated variables. After that, just run the code. What it does is fetch all the records from the specific table you specify in the code. This process makes it easy to interact with ServiceNow data programmatically, which is really powerful when you're automating tasks or integrating with other systems. Remember, this approach connects directly to the core of ServiceNow's API, enabling efficient and flexible data handling. All right, let's talk about how to secure our REST API effectively. First, one key point is to restrict the table from being accessed directly through web service calls. This means we need to ensure that only authorized requests can interact with our database tables, preventing any unintended or malicious access. Next, it's important to identify users specifically for inbound requests. By doing this, We can control who is allowed to access the API and tailor permissions accordingly, adding an extra layer of security. Another crucial aspect is implementing CORS, or cross-origin resource sharing. This allows us to specify which domains are permitted to make requests to our API, helping us prevent cross-site request forgery and unauthorized access from unknown sources. In the context of the overall security strategy, these measures work together to create a robust shield around our API, ensuring that only legitimate, authorized traffic can interact with our services. This way, we protect sensitive data and maintain the integrity of our system. Let's walk through how this process actually happens in practice. First, you'll need to go to your personal developer instance. From the All navigation bar, search for SysUser, list and open any user record. Once you're there, make sure to check the Web Service Access Only box. This step is crucial because it enables the user to access web services securely. Next, click on the header of the form, go to Configure, then select Table. This allows us to modify the table's settings directly. After that, you'll find yourself on the User Table form. Here, click on Application Access and then check the box labeled Allow access to this table via web services. This step essentially grants web service access at the table level, which is necessary for integration. Now head over to the All Nav bar again and search for CORS rules. Open that module and click on New to create a new rule. When you're setting this up, give it a clear name in the name field. In the domain field, input the domain name you want to allow, such as https://test.com. Then, select the HTTP method you want to permit, in this case, GET. Once all that's filled out, go ahead and submit. By following these steps, you're effectively configuring your instance to securely allow web service access from specific domains, which is a core part of enabling integrations while maintaining control and security. What is Scripted REST API? Well, it's a powerful way for developers to build custom web service APIs tailored to their specific needs. Instead of relying solely on predefined interfaces, they can write scripts that define exactly how requests are handled and responses are generated. This means they have much greater control over the behavior of their APIs. Developers can use scripting to manage incoming requests, process data, and shape responses, making their APIs more flexible and adaptable. Connecting this to the overall theme, Scripted REST APIs empower developers to create more dynamic, customized interactions within their systems, enhancing integration and automation capabilities across the platform. All right, let's take a closer look at the structure of a scripted URL, which is key when working with APIs. You'll notice it starts with https://instance, ServiceNow, com/, that's your base URL, pointing to your specific ServiceNow instance. Next, we have, which indicates the namespace or the specific API you're working with. This helps route your request to the correct set of functionalities. Following that is version, which is crucial because it specifies the version of the API you're using. This ensures compatibility and helps manage updates or changes over time. Then there's API ID, a unique identifier for the API you're accessing, kind of like a label that tells your system exactly what API you're targeting. After that, you see relative path, which points to specific resources or endpoints within that API. Think of it as the directory path to the data or functions you need. Additionally, on the slide, you'll see details like the instance name, scope, API ID value, resources path, and version of API. These are all important components that help you structure your URL correctly and understand the context of your API calls. Overall, this URL structure is fundamental because it standardizes how we access different parts of a service, making integrations reliable and efficient. Connecting this to our broader theme, mastering URL construction is essential for seamless API communication and effective automation within ServiceNow. Welcome to this section on scripted API configuration. Here, we're going to explore how scripting plays a vital role in customizing and automating API interactions. The key idea is that scripting allows us to define precise behaviors, making our APIs more flexible and tailored to specific needs. By automating tasks through scripts, we can reduce manual effort and minimize errors, which is crucial in complex workflows. This approach also helps ensure consistency across different environments and use cases. As we connect this to the overall theme, remember that efficient API configuration is central to scalable and reliable integrations. So, mastering scripted API setup empowers us to optimize performance and adapt quickly as requirements evolve. All right, let's walk through how to create scripted REST APIs step by step. First, you'll go to the All Application Navigator bar, type in Scripted REST API, and then open that module. Once there, click on New to create a new API. You'll need to give it a name in the name field, then submit. After that, open the Scripted REST API record you just created. Next, head over to the Resources tab, click on New, and give your resource a name. For the HTTP method, select Get since we're retrieving data. Then, specify the retrieve path, like, this path includes a placeholder for the SysID parameter. Now go to the scripting section. Inside the script body, you'll write a simple script that extracts the SysID from the request's path parameters. Then, you create a glide record object for the incident table. You add a query to match the SysID, run the query, and check if a record is found. If it is, you prepare a response object, such as a JSON body, containing only the data you want to expose, like the incident number and short description. Finally, you set this body in the response. Once you've written and saved this script, go back and click on the REST API Explorer. Here, you can test your API by clicking Send. This approach allows you to retrieve only the specific data you need, rather than exposing all incident information, which is key for security and efficiency. Remember, this method gives you control over what data is exposed, making your API more secure and tailored to your application's needs. All right, let's dive into the components of an outbound REST message. First, we have the endpoint. This is essentially the URL of the API we want to communicate with, which belongs to another system. It's a crucial part of REST message integration because it tells our system exactly where to send the request. Next, we have headers. These are important because they contain information about the request itself, such as content type, authorization tokens, or other metadata that the receiving system might need to process our request correctly. Moving on to authentication. This involves the type of credentials we use to verify our identity, whether that's an API key, OAuth token, or username and password. Along with that, we need to include the actual details of these credentials to ensure secure communication. Finally, we have HTTP methods. These are the actions we want to perform, like get to retrieve data or post to send data. The choice of method depends entirely on the operation we need to execute. Connecting this all back to the overall theme, understanding these components helps us build reliable and secure integrations with external systems through REST APIs. It's about making sure our requests are correctly targeted, properly authorized, and follow the right method for the task at hand. Now, let's take a closer look at the outbound REST message module. This is a crucial component in how our system communicates with external services. Essentially, it handles the process of sending data out via REST APIs. The key points here are about understanding how we structure these messages and ensure they are sent efficiently and reliably. The module manages the creation of outbound requests, including setting up the right headers, body, and method, whether it's GET, POST, or others. It also takes care of error handling and retries, which are vital for maintaining robust communication channels. Connecting this to the overall theme, the outbound REST message module is fundamental because it enables our system to interact seamlessly with third-party services, APIs, or even other internal systems. Without this, our system wouldn't be able to integrate or exchange data effectively, which is essential for automated workflows and real-time data exchanges. So, in essence, this module is about making sure our outbound messages are well-structured, secure, and resilient, supporting the broader goal of a reliable and efficient integration architecture. In this slide, we're going to walk through how to create a REST message in ServiceNow, specifically focusing on integrating two instances, one primary and one secondary. The goal here is to set up an outbound REST message that allows these instances to communicate smoothly. First, we start inside the primary instance. We go to the All navigation bar, search for System Web Services, then Outbound, and select REST message. We click New to create a new message and give it a name in the name field. This setup will all happen inside your primary ServiceNow instance. Next, we switch over to the secondary instance. Here, we search for the REST API Explorer and open that module. The first time you do this, you'll see a button labeled Explore. Click on it to start exploring the API. Once inside, you select a table, for example, incident from the table name field. Then, in the secondary instance, you search for incident, view all incidents, and right-click on any record. Choose Show Matching, and a link with a query will appear. Right-click on that link and copy the query. Now go back to the REST API Explorer form in the secondary instance and paste that query into the sysbarm query field. Hit Send, and you'll get an URL. Copy that URL from HTTPS to the end of the table name, as this will be used later. Switching back to your primary instance, you go to the REST message form and paste that URL into the endpoint field. For authentication, select Basic, then create a new Basic Auth profile. Enter your admin ID and password for that secondary instance, and submit. Open the recently created REST message record. Under HTTP methods, you'll see a default GET method. Open this, go to HTTP request, and in the headers, add a header with the name accept and value applications/JSON. This ensures your response will be in JSON format. Now return to the secondary instance and update the REST API Explorer form. For the sysbarm query value, paste the recent query you copied earlier. Also, you can add a limit parameter if needed. Save your changes and then test your setup. When you click Test, you should see a status code of 200, indicating the data was successfully retrieved. This process connects the two instances, enabling seamless data exchange through REST messages, which is a key part of automating and integrating ServiceNow environments. This slide doesn't contain enough information. That's why we're moving to the next slide. Now, let's walk through how to create a direct and recordless outbound REST message. Previously, whatever changes you've made, let's continue from there. First, go to your primary instance and search for business rules. Create a new rule, give it a name, and select the table as SysUser. Make sure to check the Advanced checkbox and set the when to run as before update. In the Advanced section, you'll see a script. Copy the preview script usage from the default GET method you previously created. Paste that code inside the Business Rules Advanced Script area and save your work. Next, go to the user table in your PM instance, open any record, and make some edits inside the user form. Save those changes, and then search in the navigation bar for system logs. Navigate to all, and here you'll see the response data, which confirms that your message is working. And that covers our approach to setting up the direct outbound REST message. Now, let's look at creating a recordless outbound REST message. Again, start from your primary instance, go to Business Rules and create a new one. Give it a name, select SysUser as the table, check Advanced, and set the when to run as before update, but this time filter for specific changes like title changes. Then, switch over to your secondary instance and open the REST API Explorer. Copy the ServiceNow script code sample provided there. Go back to your business rule in the Advanced section, paste that code, and update the variables with your admin ID and password. Save your changes, and repeat the previous steps you did before to complete the setup. And that's how you handle recordless outbound REST messages. So, in summary, these steps allow you to automate messaging for user updates, whether directly or in a recordless way, enhancing your instance's integration capabilities. All right, let's walk through how to send dynamic data with a REST message. First, you'll go to your ServiceNow instance, search for REST message, and open the record you previously created. From there, you'll navigate to the HTTP Methods tab, click on New, and provide a name for your method. Be sure to set the HTTP method as post since we're creating new records. Next, switch over to your secondary instance. Search for the REST API Explorer, then select the table you want to work with, in this case, incident. Inside the request body, you'll pick the field you want to populate, such as short description, and assign a value to it. Hit send, and if everything's correct, you'll see a status code of 201, which indicates the record was successfully created. Now, copy the endpoint URL from this process. Head back to your primary instance, go into your HTTP methods, and paste that endpoint into the endpoint field. Inside the HTTP request parameters, you'll need to add headers, make sure they're correctly configured, and then save your changes. Test the setup to ensure it's working properly. Finally, copy the ServiceNow script code sample provided. Create a new business rule on the incident table, set it to run asynchronously on insert, and inside the advanced section, paste the code you copied. Save everything and give it a test run. This process is all about automating data creation and updates dynamically, connecting your instances seamlessly. It's a powerful way to streamline workflows and ensure your data flows smoothly across systems. Thank you very much. I really appreciate your time and attention throughout this presentation. I hope the key points we've discussed today have given you valuable insights into the topic. Remember, the main takeaway is how these concepts connect to the bigger picture and can make a real difference in your work or organization. If you have any questions or want to explore these ideas further, please feel free to reach out. Thanks again for being such an engaged audience.